Hi, welcome to another lesson of physics. Today's class we'll see about a little bit about vectors and scalars. We'll also see the misconceptions of using average speed, constant speed, changing speed, what are the differences, and when to use equations of motion formula, all those. Yeah, we'll start now. Now, vectors and scalars. What are vectors? What are scalars? Now, vectors are quantities. I'll just give you the definition first, then I'll explain with an example. Okay. Vectors are quantities that describes the direction as well as the magnitude of any physical quantity. I repeat, vectors describe direction and magnitude of any physical quantity. Now, scalars are quantities that only describe about magnitude. They do not talk about or give any hint about the direction of the object. Now, for instance, just listen to these two statements carefully. First statement is an object travels from A to B. I repeat, an object travels from A to B covering a distance of 20 kilometers. Okay, it says A to B covering a distance of 20 kilometers. The second statement is an object covers a distance of 20 kilometers. An object covers a distance of 20 kilometers is statement number 2. Now, what's the difference in the two statements? An additional information which says from A to B. Okay. You can take a live example. Okay, a person travels from school to her house and she has covered 20 kilometers. Right, so there is an information of the direction of travel which actually represents a vector quantity, because the direction is also mentioned and you also have the magnitude. But if it is a scalar quantity, it only gives you the magnitude. That's a very simple example as in a statement. Now, coming to the quantities that are scalars and vectors. Okay. Now, distance and displacement. When I said the first statement, A to B traveling 20 kilometers, that is referred to as displacement. The object is displaced from A to B. All right. So, here if I write scalars, vectors here, examples. The first easy example would be here. Distance is a scalar quantity and displacement is a vector quantity. Right? You can relate it to the example that I told you. Here it only gives the magnitude 20 kilometers. Here it gives an additional information of direction. It should be referred to as displacement. Now, another easy example is these two, speed and velocity. Now, I tell my students a hint to remember this, V and V. Here you have S and S. So, if you just asked to define these two quantities giving an example, immediately you can give, or it will come to your mind. These two examples you keep in mind. Easy to remember: vectors, velocity; scalars, speed. Now, here, how can you explain the difference? Speed will give you only the direction. Speed will give you only the magnitude of the speed of the object. Velocity will give you the speed, magnitude and direction. Magnitude will be the speed, and it will also be giving you additional information of direction. Right? So here I have written acceleration. Is acceleration a vector quantity? Yes, it is, because it also acceleration by definition it is the rate of change of velocity. rate of change of velocity, not speed. So acceleration also is a vector quantity. Okay, a couple of more examples I'll give you. Time is not a vector quantity, time is a scalar quantity. All right, now when I discuss about other physical quantities, then I'll tell you whether it's a vector or a scalar quantity. Now we'll see about, as I told you initially, the differences between these three in terms of explanation and in terms of calculation. Now the first formula that you would have learnt in motion chapter or in forces and motion chapter would be speed is equal to distance upon time. If any student is in year 9, from I think year 6 or 7, you may have learnt this formula, right? Now when you come to IGCSE curriculum, you will also be introduced to a few more formulae that also connects distance and speed and time. Let's see a couple of them. Now the most common formula that you will be using is V is equal to U plus AT. Okay. Now this is one of the equations of motion. There are a couple of more which I may not be introducing it today, but then as an advanced class we'll see. Here we are just saying about the basic idea about, or the basic misconceptions that you need to avoid, and you have to be careful in handling these equations. All right. Now as I told you earlier, this is connecting speed, distance and time. Here also we have speed, here also we have time, and additionally we have got acceleration here. So most of the students tend to confuse with the calculations, or confuse in choosing the right formula for any calculation. I've noticed majority of them, especially in year 9 when they start IGCSE curriculum, if they see speed and time, they immediately write this formula. Okay, speed is equal to distance over time. I'll tell you when to use this and when not to use this, right? Now this formula actually stands for constant speed. Okay, if the speed is not changing, if the object is traveling at the same speed throughout a journey, then you will use this formula. So for constant speed, you can use the total distance covered upon the total time taken. You will get the correct answer. There is one more place you will also be using this formula for finding the average speed. Okay, so two places you'll be using distance over time formula, where one is when the object is traveling at constant speed, is not changing, the journey, the portion of the journey that you're considering, the speed is being constant throughout, you'll use distance over time formula. You can also use, if it is velocity, displacement over the time taken also. So that's for constant speed or constant velocity. Now average speed is something that, what's the difference between average speed and the actual speed? I'll give you an example. Say an object starts from this point. Here it's traveling at 30 kilometers per hour. So it is traveling for about, say, it's covering some A to B. Then it's covering a distance of, we'll take the distance. Okay. Here it covers 30 kilometers in say 1 hour. Okay, here it 20 kilometers in 1 hour. Like this, the speed keeps changing. So here the speed is 30 km per hour, here it is 20 km per hour. Totally it is covered 50 kilometers. Now if you are asked to find the average speed of this journey, what do? You take the total distance covered divided by the total time taken. So what is the total distance? 50 upon 2, you will get 25 kilometers per hour. Okay, so your average speed 25 kilometer per hour for this journey. But if you look at it, is it traveling with this 25 kilometer per hour at any point in this journey? No. isn't it? Because for the first hour it is traveling at 30 km per hour. For the second hour it is traveling at 20 km per hour. So at no point the object is traveling at this speed. It only gives you an average estimation of this entire journey. Okay, it is not equal to the actual speed. So I go back and repeat this formula. You will be using it in two places, where when you are using it to calculate constant speed, when you are using it to calculate average speed. I'll come to this constant speed. Constant speed is like you're using, see, this 30 km you're substituting here, 1 hour you're substituting, you're finishing the calculation, you get for A to B the constant speed answer. Now, when do I use this formula? Okay, or any of the equations of motion formula? Okay, here there is a condition when the acceleration is equal to constant. Okay. What do you mean by acceleration being constant? What's the difference between acceleration being constant and velocity being constant? You have to be very clear about it, because this is the area where students get confused. Velocity being constant is the object is traveling at the same speed. There is no increase or decrease of the speed. Now, acceleration itself means what? There is a change in velocity, correct? Acceleration is change in velocity. Now, if I say acceleration is constant, that means the change in velocity is constant. Getting it? There is a change in velocity, but the change in velocity is constant. We see it in an example. So I'll divide it into like few seconds. For this is 2 seconds, 3 seconds, 4 seconds, and say 5 seconds. Constant acceleration meaning, say for example here the object is traveling at 10 meters per second square speed. So the first minute the object is traveling 10 meters per second square speed. Now for the second it is traveling at 20 meters per second speed. Third second it is 30, fourth is 40, fifth is 50 meters per second. Now, is the object maintaining constant speed? No, the speed is changing. It is increased from 10 to 50. It's a steady increase. Now, if you notice, for every second the speed has increased by 10 meters per second. Do you agree? For 1 to 2 it is increased by 10 seconds. Here also there is an increase of 10, here also there is an increase of 10, here also there is an increase of 10. So the object speed is increasing, that means it is accelerating. How is it accelerating? It is accelerating uniformly, or it is accelerating constantly. What is that value? Acceleration is increasing by 10 meters per second for every second. So that value is constant here. Now say another situation where, or this is object A, another object, it starts with the same speed, 10 meters per second, right? Then the second it jumps to say 50 meters per second. Then third second it goes to 55, then probably 60, then 62.5, like random. But is there any increase in the speed throughout? Yes, there is. For all these 5 seconds the object's speed is increasing, but what is it increasing uniformly? No. Here there is 40, here there is 5, here there is another 5 and 2.5. So there is a fluctuation of speed. It is not constant. So this will be termed as non-uniform acceleration. Okay, so this is uniform acceleration, this is non-uniform acceleration. Now we are not going to talk more about non-uniform acceleration, just for your understanding. What you need to differentiate is what do you mean by uniform speed, what do you mean by uniform acceleration. Okay, uniform speed is constant speed throughout. Uniform acceleration is the change in speed or the increase in speed is being constant. All right. Now, the first formula, as I told you, speed is equal to distance over time, you will be using only when speed is constant. Okay, speed is constant. The second formula, which I told you, v equals u plus at formula, you will be using when acceleration is constant. That is the condition. On simple terms, if the object is accelerating, then you cannot use the formula speed is equal to distance over time, because it is not maintaining the uniform speed. Every second the speed is changing. Hence, if you apply this formula, you will get the correct answer, because acceleration has to be included in the calculation. Clear? Now, so summary, we'll see constant speed, you'll use the formula speed is equal to distance over time. Now, when it is constant acceleration, you will use v is equal to u plus at formula. As I said, there are a couple of more formulae with equations of motion. We'll see it in a separate session. Now, here one question: what is the acceleration when speed is constant? Can you think and tell me? If the object is maintaining uniform speed, is there any acceleration? Like, you can think about, in a car when you are traveling, if there is no acceleration, then the object will be maintaining uniform speed, correct? So here acceleration is 0. So the object will travel at constant speed when acceleration is 0. You will use the formula speed is equal to distance over time for any calculations. Now, constant acceleration meaning the object increases the speed by the same amount for equal intervals of time, and you will mostly you will be using v is equal to u plus at. Now, I didn't explain what each alphabet stands for. Here v stands for the final velocity. When we say acceleration, it has increased, say, from 5 meters per second to, say, 20 meters per second. Say the time taken for this change is, say, 5 seconds. Okay. Now, v represents the final velocity. U represents the starting velocity or initial velocity. A is the acceleration, obviously t is the time taken. Now, here we know v, we know u, and we know t. If you want to find a, what you would do, just change the subject of the formula. So here a will be equal to b minus u upon t. So if I plug in these values, 20 minus 5 upon 5, I'll get 15 over 5, which will give me 3 meters per second square is the acceleration for this situation. Getting it? Later we'll see a few more examples, including final speed, initial speed, distance, and so on. Okay, I hope you have understood at least to a certain extent, because only when you practice more questions, theory and numerical questions, you'll come to a clear understanding. But this what I explained here was to just avoid, try to make you avoid silly mistakes, because before using that formula speed is equal to distance over time, please give it a thought whether it is appropriate to use it in that place or not. All right. Now, more examples and more explanations will follow. See you later. Bye.